observer. Behind the curtain, you put a computer and another human. And if this person, which is behind the curtain, cannot see the difference between the computer and the human being during some question-answer test, then the computer machine has passed the test. Intelligence is another definition from Scholle, who is actually working for Google. Intelligence is not a skill itself. It's what you can do and how you manage efficiently what you haven't seen. In other words, he's pushing us into a test set. If you haven't seen something and you manage it very well, efficiently, then we can call you as an intelligent agent. Today, artificial intelligence, and tomorrow. So devices that currently designed our intelligence are defining into three parts: the narrow artificial intelligence, the general AI, and artificial superintelligence. That's what Stephen Hawking tells us about. That's a warning to the humanity, because it may be very dangerous to reach this point of artificial superintelligence. But even general AI is difficult to achieve, and we're going to see this through these slides. So narrow AI, currently we can say that all corporate organization or industrial company working in Industry 4.0, or those dealing with Health 5.0, are dealing with narrow AI. Narrow AI consists of developing platforms that perform face recognition, autonomous vehicle, provide guidance in hospital, and all this intelligent system would fall into this category. So you can see here driverless car. So there is a program that makes this car, the recognition, image processing, signal processing, and make this drive without any driver, and also guidance during the hospital and recognition of people in the street. These are all fall into this narrow AI. General AI is what we call the anthropocentric aspect of artificial intelligence, because that's what we want to create programs that imitate a human brain cognitive system. So general artificial intelligence is far from being achieved. It's, for example, as Wozniak has given this example, an agent is called intelligent if he or she can perform the following task, the coffee test of Wozniak. A machine is required to enter an average home and figure out to make coffee. If the machine can find the coffee, if it finds the coffee machine, if it finds the coffee, if it can add water or pour water, if it can find a mug and brew the coffee by pushing the proper buttons, then this agent is called intelligent, but in the sense of general AI, because it's really mimicking the human being. The third point, the third class of artificial intelligence is something that is quite dangerous for us humans. It's superintelligence. It's an intellect that is much smarter than the best human brain. It's something that outsmarts us, more creative, with social skills. So a machine capable of constantly learn and improve itself could be unstoppable. It can solve equations that human being has never dared to solve. It can go faster than us, and it can, at the end, maybe control or monitor us as a human. Machine can learn. So what does it mean, machine learning, compared to traditional software? We can say that there is a revolution brought by machine learning, because there is no such programmer that is capable to say, here's code, and tell the computer what to do in each iteration, each step. The machine is capable to learn, improve performance without being programmed. That's really what matters. That's really what brings this new insight into machine learning. The emphasis is on learning instead of programming. It requires, of course, massive amount of data, IoT, cloud, fogs, or edges in order to start this huge, immensity of data. We would like to discover data, to learn patterns from data, associate patterns, classify cluster, and predict new data. The example of a machine learning, we call it a shallow learning, shallow versus deep learning, because deep learning resembles or mimics the human brain. But the shallow learning is just, for example, one hidden layer, a neural network with one hidden layer. There is no such bunch of layers that make this compositionality of information, which is inherent to deep learning. This is just a shallow learning. And you can see this difference between conventional programming, when the programmer sits down and code, thinks about every iteration what to do and give order to the computer. Unlike this conventional programming, machine learning relies on data and try to twiddle those parameters inside a model. So machine learning is characterized by a model with parameters, and this model learned through data. All the information is given by data. If you don't have data, then there is a problem. We cannot use machine learning. So training prediction, what really matters? How do we want to measure the quality of a machine learning system? There are two parameters, the variance and the bias. What we want to reach here, we want to test the machine on new inputs, but the result of all the new test machine should be congregated with a small variance, as well as around the truth, what we call the bull's eye. In other words, what we want to achieve is a low bias and a low variance. It's not always easy to achieve this, to minimize these two parameters, but globally, you will see that any system has its own drawback, and it will be difficult for us to minimize those variance and the low bias at the same time. What is the mathematical motivation of deep learning? Many people ask the question, where is deep learning has been created, whether in Russia or whether in United States and England? So there are some work found in Russia that shows that deep learning has been found as a 13th problem of David Hilbert. David Hilbert is a German mathematician. He posed 23 problems, and one of the problem is really related to deep learning. We call it the 13th problem among the 23. Hilbert posed this problem and considered the 7-degree equation x power 7 plus ax power 3 plus bx power 2 plus cx plus 1 equals 0. And David Hilbert asked the question whether the solution with respect to x as a function of three variables a, b, and c can be expressed as a composition of just two variable functions. If yes, then this is really similar to what we call deep learning with two hidden layers. And you will see that the contribution of the Russians here is prominent. Kolmogorov-Arnold representation theorem. Arnold was a student of Kolmogorov in the University of Moscow. So he provided the solution to the Hilbert 13 problem by this theorem that he has proven. So it's named Kolmogorov-Arnold representation. A continuous function f of n variables can be expressed as a finite combination of sum and composition of just two functions in single variable, which are denoted by phi and psi. And you can see here that any function that is continuous, any multivariable variate function can be expressed as two hidden layers. Why two? Because there is a composition of these two functions, phi and psi. But then the question that is, the Kolmogorov-Arnold representation theorem was proposed as a solution to the Hilbert 13 problem. It decomposed a multivariate function into an interior and an outer function. The interior was phi and the exterior was psi. A similar structure as a neural network with two hidden layers. And you can see the two hidden layers are those functions that are composed. There is a long-standing debate, however, whether the KA, the Kolmogorov-Arnold representation theorem, can explain the use of more than one hidden layer. Because nowadays, deep learning is characterized by more than two hidden layers, but it started, its mathematical proof was with two hidden layers, with this theorem, KA theorem. You can see here the graphical representation of deep learning. We have so many pictures here, and we can put this image into multiple layered neural network. And the input layer is here at the left side. The hidden layer may be 50 hidden layer or 60 hidden layers are then composed. These are what we call the composition function. And then there is an output layer made of a fully connected neural network. And this composition, why we put this composition in a hidden layer, and this may be something novel compared to the shallow learning, is that this first layer tried to identify lines, edges, As far as we go through deeper, through the other layer, then we can identify other shapes like circle, like square, and then at the end, we're going to identify a face of a human. So it started with, you know, it's kind of a bunch of concepts that are put forward one after the other. The first concept, which is maybe the starting concepts, are straight lines, edges, corners, and then we go further in trying to recognize more complicated shapes, and in the end, trying to identify faces. So this is really the idea behind deep learning. What characterizes deep learning? It consumes a massive amount of data, of course, and computing power. It's very difficult to work with just a simple PC, personal computer, and try to execute a deep learning function. That would be maybe difficult. Deep learning is simulating human cognitive systems, what we call promoting anthropocentrism instead of ecocentrism, which rely on knowledge based on animals or trees, vegetation, and so forth. But deep learning is trying to mimic the human brain, especially the human. So it imitates the human brain's connectivity. It allows to classify data, find correlation between them, and exhibit high performance for some applications such as image recognition and the natural language processing. And you can see here that deep learning is not capable to, once you can see this, the difference between a shallow learning, which is on top, and then deep learning. Shallow learning use just one hidden, maybe one, what we call support vector machine, or one neural network with one hidden layer, but it gives us some explainability, whereas deep learning lacks the interpretability. What does it mean, interpretability? It means that we can observe the cause and effect within a system. We may not understand what the relationship between the cause and effect, but at least we can observe it. And the second point that is lacking in deep learning is the explainability. Many people really are unhappy because, especially medical doctors that try to understand what's happening inside results of deep learning and try to ask or to query the machine, telling that, why did you get out with these results? So they fail to have this test. So explainability, unless interpretability, is the extent to which the internal mechanics of a machine or deep learning system can be explained in human terms. So we have to make this difference in order to understand what is lacking in deep learning. Contribution to a global economy. It's produced, so deep learning promote the production of smart machines that analyze and diagnose issues without human intervention. I told you that everything is learned from data, and the machine does not need to be programmed. It's part of the Industry 4.0 because it takes machine learning to one model in Industry 4.0. It increases productivity. It minimizes human error, training beginners in field, for example, reduce production cost, eliminate downtime equipment via predictive analytics. Machine learning model, sorry. In machine learning, a feature is a numerical representation of raw data. A model is a mathematical structure representing a real-world situation. So basic training strategies in deep learning are, for example, supervised learning, unsupervised, reinforcement learning, semi-supervised, and there are so many techniques that we have proposed in the literature in deep learning in order to train. You can see on the right side here, we have a classification that delineates between two classes. We have correlation here, and we have what we call clustering or unsupervised mode of learning. Oil industry is now driven by effective data management, but machine learning will decide its future. More data sets allows observing trends, learning patterns, making optimal decisions. So this is extremely important in society, whether it's industrial or any type of society, because it prevents failure, it locates resources, it provides an optimal management of resources, workload, detect, anticipate problem to achieve zero incidents. So for just an example of predictive analytics for future cost and price, and you can see here that this models of deep learning allows you to predict what will be the future price of oil in the oil industry, for example, of the barrel. And you can see what's green part graph is the past. So it relies on the past and provides a prediction to the future. Same thing for with the question that we ask here is whether will the equipment fail in 6 months. So knowing the equipment that fail help a lot in what we call maintenance or renewal of the equipments. So we can see here, same thing, we have 2 sensors that are put forward in order to collect some data. And those data with a model allow us to answer this question, whether the equipment will fail in 6 or 1 year. Question 2, when to renew equipment. So what matters for companies is to be proactive. So we need to replace the equipment before this equipment will fail. So there are this, unlike SCADA, which has been used most of the time by companies, some companies nowadays are using machine learning. They collect data over time to monitor the state of equipment. The goal is to determine patterns that help predict and as well preventing failures. Machine learning is actually being used in remote sensing, and we have our speaker today that give us some detail about the use of remote sensing. But we have worked on land cover chain detection, which is based on intelligent remote sensing. Our goal was to monitor the desertification from one period of time, 2004, 2009, 2007, and try to track whether we have this process of desertification. And land cover here on a map, which this map is spawned by satellite images, and it includes grass, asphalt, trees, bare ground, water, snow, etc. So the goal is to monitor the desertification process. Machine learning is also being used in Health 5.0, so where data is connected, completely connected and interacting, exchanging information with a human, centering around a human. So this is this integration of a human inside it. The ecosystem and digital wellness, to be proactive rather than say, I'm feeling good, but say try to measure all our most important data like blood pressure and heart disease and all these kind of things, and not being, trying to be proactive. And that's where machine learning is allowing us to be proactive. So Health 5.0 is defined by the production, industrialization, the automation, digitalization. And the most important thing that is new is personalization. We're expecting that personal medication, idiosyncratic analysis, which really is valid on a one human and not valid on another human. So I would say medication on demand will be our future discovery. Radiotherapy as well, and you can see that the data are collected, disease and patient data, treatment data, and the machine learning work and that, and it's capable of improving the accuracy, the overall quality of radiation for patients with cancer. AI platform excel also in the identification of complex pattern in clinical data and also allow assessing quantitatively clinical conditions. So the question then, we are talking about the pros of machine learning or deep learning or artificial intelligence, because artificial intelligence is nowadays centered around deep learning. So what are then the limitations? This is a very important question. First of all, deep learning requires a large amount of annotated data. Annotated means labeled. If you don't have a large amount of data, you cannot use deep learning. We try to augment those data by, some operations, padding, flipping the images, and so on and so forth. Deep learning very often overfit the model, means that we'll perform very good in the training set and sometimes very poorly in the testing set. In order to mitigate this effect, what we use in general, what we call regularization, like the dropout technique, for example. Deep learning perform well on benchmark data set, but can perform poorly on images outside the data set. And you can see those images, for example, a baby on the road here. Nobody have seen so many babies on the road. Then if we have a car that is driverless, we don't have any driver, then this car might cause an accident and go over this baby because There are not many images where a baby is on the road and this baby is alone. So that's the reason we call this overfitting, depending on the data that you have provided. They are also overly sensitive. It makes some correlation. For example, here you can see a guitar on the tree, but a guitar cannot be on the tree. The relationship is because there is a monkey, and this monkey brought a tree because a monkey is on the tree. So there is this correlation that makes things that should not be together, that make them together. Now, the question is, why deep learning fail within industrial companies or corporate? Because there are 4 different causes of that. The first one is use of poor quality data. Data are not cleaned, or maybe there is an absence of data record. Many companies, even here, in some countries, they don't have enough data. If you talk about, did you get some record of this data? They will tell you maybe not, or maybe it's not very sufficient. The amount is very small. The second one is shortage of technical expertise. So human resources need to be solicited in order to hire technical expertise, means those having those technical expertise of machine learning. And lack of management buy-in and commitment. Companies has to be committed and to believe in that in order to succeed in exploiting deep learning algorithms. And as well, failure to have a need for DL. Sometimes there is no need for DL in some companies. What will be the future trend of DL? So artificial intelligence, we say artificial intelligence or DL, they are used interchangeably, means we can use DL in the place of AI, because AI is now focused on DL, deep learning. AI should not be described solely by a shallow learning or a deep learning. It happens that it has to integrate or incorporate cognitive models to hopefully achieve artificial general intelligence, which is really the main goal of artificial intelligence, trying to build agents that communicate perfectly, seamlessly with a human. So cognitive modeling is difficult to be programmed because it can, for example, it forces us to describe perception, emotion, and many other physical reasoning, causal reasoning, spatial reasoning. These are all lacking in current DL algorithms. So we need to go toward the hybrid knowledge-driven representation. That's what should the future be. Hybrid knowledge-driven reasoning-based approach centered around cognitive models provide a richer, more robust AI than is currently possible. We need to explore the environments. In other words, we need to observe how a baby learns. Instead, teach in the way a baby learns. We should not force a baby to learn in the way we teach. That's exactly what's the moral behind. Babies are extremely good in learning how to learn. They drop objects and they see what is happening. They explore the environment. All these, cognitive aspects in the baby has to be embedded inside a deep learning model in order to achieve this artificial general intelligence. Kirk-Gödel incompleteness theorem is a very powerful theorem that helps a lot to drive us. What Kirk-Gödel, which is a famous mathematician, told us, just in a nutshell, anything you can draw a circle around cannot explain itself without referring to something outside the circle, so that you have to assume but cannot prove. So I believe, this is just my personal view, I believe there is a difference between learning and reasoning. And learning is one circle, but reasoning is the bigger circle that contains learning. And this reasoning is also using on pieces of information that are human hardwired. They are in our genome. They are part of our creation. This is my personal view. Conclusion remark. Narrow AI is widespread. So if you talk about the impact on society, we're going to talk about narrow AI, because this is really what's being achieved nowadays in many companies around the world. But it's not ubiquitous. It should exploit also ecocentrism. It should also try to observe how animals behave, how trees are functioning, the mechanism. And this is beyond anthropocentrism, which is centered only on a human. This algorithm can predict what may happen. They decide, they self-learn, they communicate in natural language. However, they are far from competing with human cognitive abilities expressed via artificial general intelligence. Thank you. And I will give talk to the moderator. I finished my talk.
Thank you, Professor Bouchaffra, for your interesting talk. Now, thank you, Professor Bouchaffra, for your nice talk. Now we have the time of question. Is there any other question? So we have not yet. Okay. We have the question of Faisal. He asked you, Professor Bouchaffra, do you think that cognitive science can create machines that surpass the capacity of human intelligence and ability?
Certainly no. The answer is no, because it's not always easy to implement cognitive abilities, like, for example, emotion in a machine. What will be emotion in a machine? And this is quite difficult to code. So I think we need to go toward this, but I think human being is equipped with more than cognitive abilities. And it's very difficult to achieve general artificial intelligence if this is the question.
No question? Really? Is there any other question? Okay. Okay. I want to ask you, Professor Djamel, what's lacking in current AI?
What's lacking? Yes. Yes, indeed. Current AI is just because AI, which is centered around deep learning, is depicting or identifying only correlations between features, and that there is no such things. If you give me a lot of data, then definitely current DL will try to determine those correlations in order to say that this image belong to a cat or rather than a dog, for example. So you have to give me a lot of images of cats and trying to correlate between them. So this cognitive aspect of causality model is definitely lacking in artificial intelligence, actually. But there are some people working on that, and hopefully we will certainly be able to achieve more than what we have achieved, which is described by neuro artificial intelligence. And those who at all companies, many companies in the West are currently, or in the East as well, are currently using or trying to exploit. But there is no such artificial general intelligence being exploited nowadays in these companies, rather than narrow AI, but not in all the applications, because there are some applications where deep learning also fails.
There is another question, Professor. Do you think from Zelagi Iskandar, do you think that super AI may try to end its own existence? It backfires.
Yes, that's what many researchers fear, that super intelligence one day will be available, but we don't. So far, we will not say that in a decade super intelligence will be, because even artificial general intelligence may not be available in a decade, or maybe in 20 years. Hopefully, we hope that artificial general intelligence will be available in 20 years, but super intelligence, if it will appear, definitely this might harm human being and in their creation. Absolutely, because it can go very fast. It can be extremely intelligent, and with a huge amount of database and all that, we will be unable to do things by ourselves, but we'll be always monitored. This is something that everyone is fearing. Yeah, indeed.
Another question from Khaled Lunas. Can deep learning overcome the problem of lack of data? In other words, can lead to optimal models with little data?
Yes, in its current description, if you look at the algorithm proposed in deep learning, we don't have something that, something that is reliable on having a small data set in order to accommodate this big number of parameters inherent to deep learning. We have maybe, what we can do is to regulate, just make some regulations like dropout, for example, removing some neurons from the network and try to, because of human doesn't need a lot of neurons, because we say that human is lazy in the brain because it has to rest. And this part of resting, which is inherent, which is hardwired in our creation as a human, is that it enabled to prevent overfitting. This is the reason why only very few of neurons are working at the same time in our brain. And we call this the lazy brain. But absolutely, because of this overfitting, because it makes the model simple and simpler, and that's what is characterized, maybe mimicking in the dropout algorithm of Geoffrey Hinton.
Oui. S'il vous plaît.
Yes, we are hearing.
Oui. Madame Allette. Oui, vous m'entendez?
Welcome.
Oui. Monsieur Bouchaffra, bonjour. Hein? Je voulais seulement savoir, est-ce que vous m'entendez?
Yes. Oh oui. Je l'entends un peu.
Oui.
Difficilement, mais je l'entends quand même.
Vous m'entendez?
Difficilement, mais j'entends quand même. Allez-y, professeur.
Non, je voulais seulement savoir comment vous voyez l'avenir de l'intelligence artificielle chez nous. L'intelligence artificielle chez nous. L'intelligence artificielle chez nous. D'accord. Je coupe.
Vous pouvez répéter, madame?
Non, je voulais. Ça marche maintenant?
Est-ce que chez nous?
Allô?
Madame, est-ce que vous pouvez écrire votre question?
Sans ça fait rien. Tant pis, je la formulerai après directement, monsieur.
D'accord, merci.
Merci beaucoup.
Est-ce qu'on utilise l'intelligence artificielle? Je peux répondre à ça. Chez nous, elle a dit.
Non, chez nous, vu qu'il faut un nombre...
Oui, je peux parler.
Oui, allez-y.
Well, I think maybe whether the question is whether we are using artificial intelligence in Algeria, right?
Yes.
Yes, there are some centers, some companies that use a shallow learning. They are actually using artificial intelligence, like Sonatrach, like Sonelgaz. And they are indeed using the shallow aspect of artificial intelligence, not the deep learning, but the shallow aspect of it. Why? Because deep learning requires a lot of data. And sometimes those companies, they don't have a big amount of data available or stored. They have to build it. And there are not many companies that, that take care so much about those, the need of having a big amount of data stored somewhere.
Thank you.
I don't know whether she can.
Professor, we have the last question. Yes. So from Badis, who asked about the privacy problem in deep learning. He said, do you think that federated learning can provide a solution to this issue?
Right.
He asked, do you think that federated learning can provide a solution to this issue?
The privacy problem in deep learning, so far I haven't heard that much about this concept of privacy problem in deep learning. I'm not familiar with federated learning, but the things that is maybe very important in deep learning is that the time spent during training. What we do actually, what Google is doing at IBM, they are building what we call pre-trained models for deep learning. they have already pre-trained those models. So what we call this is part of transfer learning. If there are two actions, for example, two tasks that are similar, if someone has already trained the model, we just need to borrow these training parameters, but on condition that the first task and the second are similar, they are alike. That's what we've heard, but I'm not familiar with federated learning. I'm sorry for this.
Thank you, Professor Bouchaffra, for your nice talk.